Hello, in this video I'm going to show you how to come up with a bar linkage mechanism. Actually how to generate the dimensions of the links so that when you want to achieve a certain motion, you can easily generate them without designing the part first, then design another one, then you just try to test, then it fails. So I'm going to show you a simpler way where how you can do that one. So I'll just start a new part, not the part. So from the part I just select the part, then click OK. So when it loads, I'll start a new sketch. I'll use lines, so I'll select my plane, front plane, click OK, go to sketch, and pick on a line, click on a line here, then you just start from the origin here. So basically we have got 4 components of a bar linkage. We've got the base, the one which is fixed. We have got also the crank and the coupler, and also the other one. I'm forgetting the name. So this is our base, so you can make it a construction or just a complete line. There's no harm in doing that. So I'm going to make this one, let's say 100 mm. Then click OK. Then dimension for this one, let's give it maybe 150 or 200. I'm just using arbitrary dimensions. 200. Then from here to here, you can give it, let's say 50. Any dimension. And this one here, just give it, I need the aligned dimension. Let me give it 100. Let's see. Then this one here, I give it, let's say 90. So with that, I'll not define this sketch fully. I've not defined it fully, so that's why you can see it appearing in blue color. Each sketch is in blue color, so that means it's not fully defined. So to fully define it, maybe you can give the angular dimensions. So but for this case, I don't need those angular dimensions because I need it to move. If I drag a certain point, it should be moving. So basically the mechanism I want to achieve is the one whereby this link here is supposed to be moving in a circular manner, like oscillating back and forth. So this is my crank. So let me try to move the crank. This 100 acts as the crank radius. So I'm trying to drag it, but it's not moving in the clockwise direction. But if I try to move it in the anti-clockwise, it will move. You see, it's moving, then it reaches a point, then it locks. It cannot move further. So the y, if you take 100 plus 90, that's 190. 100 plus 50, that is 150. So it means it reaches a point whereby the 100 plus 90, it reaches a point whereby, like the dimension from here to here, it's adding up to like 150 cancelling with this other one, or it's a dimension which is more than 150, so making the link not to move further, or the mechanism to move further. So you see, so I can't achieve that motion where though I can move it, it can move back and forth, but in a restricted direction only. Like if I want this crank to, but I need the crank to move continuously in a circular manner. So let me try and modify it once again. Let's say this is 30, 60. This one, let me leave it at 100, then 70. It's just a matter of trial. Then if it fails, you see, this one is moving actually back and forth, and the crank is making complete rotation, 360. So you can see. So with this, you see, you can achieve the motion where you want the crank, maybe it is driven by the motor or an IC engine. So an IC engine, you won't limit it to move only a certain angle, so you have to move it. It will be moving a full rotation. So this is the crank. The motor is mounted here, then it's connected to this other link here. So you can see, maybe let's say, for example, a windscreen wiper of a vehicle. So you can see it will be moving back and forth as it clears the screen, or as it cleans the screen. So you can see the advantage of a good mechanism or for-bar mechanism, whereby the dimensions are appropriate. So you can modify according to your need. Then now after that, you now generate a link, design a link, each link whereby maybe the dimensions suits the generated mechanism here. Let's say from center point to this, and from this point to this point is, maybe you give it 70, then this one is 60, then this is 30, if you want to achieve maybe a certain motion of this kind. But it will also depend on the size of the design you need. So the dimensions are prone to, or are will actually change according to your specifications. So the reason as to why you can see it is going complete rotations is because 30 plus 60 is 90, and this is 70. So it means by the time this 70 reaches the horizontal line, this other one, you see, it is surpassing this is 30 plus 100, so it's at 130. This link plus this one is at 130. Well, by the time this point here, which is 70, reaches aligns with the horizontal, so which means with that the motion will still continue, and you see, and they start moving backwards. But let's try to invert them again. Let's make them this 30 and this one 60. Let's try. It is not moving. This way it's moving, and it is locked. So for that reason, you see, the crank should be shorter than this other one, this other link here. So to achieve a full rotation where the crank move continuously. So that is done. So with that, thank you for watching, and continue learning SolidWorks at Vincent CAD/CAM modeling and designs. So thank you.